In this video, I'm going to take a look at answering the question, your philosophy on homework, and do this subtraction problem of rational expressions with different denominators. So let's jump into them. Your philosophy on homework, so the original question was actually it was something like, how do you stagger homework, or like how do you focus homework on different ability levels, like something about skill level homework based assignments. So I just wanted to turn that into more of philosophy on homework because that's really a loaded question. My philosophy on homework, I'd say from now until 6 years ago, has vastly changed. And back 6 years ago, when I first started teaching college full time, and even when I was teaching junior high, my philosophy on homework was I wanted it to be short, very specific assignments, like 6 to 8 problems. Like even that was probably more than I would typically assign. Like it'd be more like 4 to 6, but sometimes 8 depending on the type of content. But I wanted the homework to be focused. I wanted to be do all 8 of these problems, do them all 100% correct. Make sure you know how to do all these problems. Don't just go through them just to do them and complete the assignment. I wanted them to be done accurately. Because what I found, especially with the certain levels that I was teaching with 8th grade, was that students don't care about homework. They just try to get it done and then they move on, especially when you assign them 20 to 30 problems. They just look at that as like 20 to 30 problems is a lot of problems that I have to get through. So I want to try to go through quickly, because if I spend 5 minutes per problem, like this is really going to add up to some time that I don't have. I didn't want that. I want the homework assignments to be 6 to 8 problems. So that way, even if they spent 10 minutes on a problem, they'd be spending an hour to an hour, hour and 20 minutes, probably even less, because these problems are not going to take them 10 minutes. But that's the philosophy that I had. I wanted them to do them accurately. I wanted you to look at a problem and really understand that problem, and not just look at it as like, oh, I got 23 more of these problems. I don't know if this is right or wrong. I'm moving on. Didn't want that. So that was early on in my college teaching career, but the back half of my teaching K through 12 career. Then when I started teaching college, I still had this philosophy. But as the years went on from there, I kind of adjusted that philosophy, because I was noticing that 8 problems is not really enough for some of the classes. Like when I started teaching business calc, I still tried to keep that down, even like Calc 1 and stuff, not just business calc specifically, but Calc 1. I still try to keep the assignments really short, but it was really difficult. Like they'd start leaking over to like 10, 15 problems, sometimes 20. I really try to keep it under 20 problems depending on the content, but it was really hard to keep it underneath 10. So then I started shifting a little bit more, and I went to the approach of, here's 20 problems to do for homework, but I'm only going to grade 4 of them for accuracy, or 2 of them for accuracy. So I still had the focus on, I want you to get these specific problems correct. Like I want you to make sure you know how to do these problems, but definitely do the rest of them. But these 4, I'm going to grade for accuracy. So those are the only problems I was looking at. Then I'd give completion points. I pretty much did that all the way through up until this past semester, this past spring that I just taught. And I changed after that also. So I would assign problems out of the textbook. Then I would also assign problems out of MyLab. I know how students go through MyLab. I know what that's about. There's a lot of just clicking through it, getting through it. When I see students working on MyLab assignments, for some reason I don't see anyone writing anything down. Like it doesn't. When I'm working on problems out of a textbook, I write it down, I do it, and then I solve it and look at my answer. But there's this like mindset with MyLab that I shouldn't need to write anything down because it's on the computer. And I tried to tell my students, write the problems down so that way you have them, you work them out. And I'm not saying everyone does this. I've just, from what I've seen in the past, I have seen some students just click and try to figure it out that way without actually writing it down. But that's not the majority. I'm sure the majority does actually write it down and work through it. But with MyLab becoming such an emphasis, AI becoming such an emphasis, and just the ability to take your phone, take a picture of a problem, and it's done, that was really starting to come into forefront recently. So this past year, I changed my philosophy due to one specific assignment. So I was teaching an elementary algebra class. I had about 3 sections, I think, at the time, an online section and 2 face-to-face sections. Yeah, so I had 3 sections. So about 50 students, let's say. It was like probably 45, maybe 50. And I gave an assignment. It was in it was elementary algebra. It was in chapter 5. It was the synthetic division and long division problems. So I assigned a problem that said, perform long division on this. It was like x squared, let me think, minus x minus 6 divided by x minus 3, I think it was. Yeah, that was the problem. So the setup should have been long division. Should have been this, x minus 3, x squared minus x minus 6, and then you should have went through your process of getting x times x, negative 3x, and so on, and you go through subtraction. I should have saw that. 50 students. This was the assignment. It was out of the book. I had them do a problem like that. Well, I don't know if this is the exact problem, but it was a version of this. Here's what I saw on probably, out of these 50, out of at least 15 to 20 of the submissions. I'd say 15 to 20, at least. This is what I saw. I saw x squared minus x minus 6 factors to x minus 3 times x plus 2. And then I saw this, divided by x minus 3. I saw that, and I saw the answer of x plus 2. This is correct, but this is chapter 6. This is intermediate algebra. Sorry, that's not even chapter 6. That's chapter 7. Yeah, that's intermediate algebra. I was teaching elementary algebra. So that was chapter 5 in that book. The students who did this method shouldn't even known that. So the proof was that 15 to 20 students took their phones, took a picture of the problem, and if you don't indicate to AI or your phone, if you're using like Symbol Lab or any sort of math editor, which again, I'm not against that technology at all. I use Symbol Lab all the time. But if you don't prompt it with using long division or using synthetic division, it will do this. And I graded 15 to 20 of these assignments, 15 to 20 of these papers, and I could have really made a big deal about it, but I was just like, okay, like clearly there's a gap here between the homework that I'm assigning, whether or not I think it's a lot or not a lot, where I think these focused problems, like 4 problems, like they're submitting these graded problems incorrectly. This was one of the graded problems, and 15 to 20 students did the method from whatever technology source that they used. So that was really the ending point for my grading for accuracy on those homework assignments, because students weren't even doing them for the purpose that they were intended for. It was just, let's get through this assignment and be done with it. So now recently, I've lowered my percentage of homework. I used to have a little bit of a bigger percentage, like 20 to 25% on homework, because there is a strong emphasis on homework. That was my philosophy 6 to 10 to 12 years ago, was homework's really important. You need to spend the time, do 2 to 4 hours of homework if you need it, do all the problems, make sure you know all the problems in and out, backwards and forwards, memorized pretty much, and you'll be fine. But now with my lab coming into play, it's really hard to get that mindset back on students, where it's so heavy in schools right now, where the my lab is just, it's hard to fight that battle. And so I've just used my lab a little bit more heavily now, and hoping that that philosophy on the emphasis on homework is just on the students who want to have that philosophy, who are going to take it upon themselves to make sure they know how to do the homework. But this problem right here that I just pointed out, this was the evidence. that was the, what's the saying, the straw that broke the camel's back or something like that. Like that was it. That was the ending point for my assigning problems out of the textbook, hoping that students were actually taking it serious and really trying to go through it. It was a lot. It was at least 15 to 20, and I could have made a big deal about it. I could have technically like accused them of using AI or cheating, but I didn't really want to go down that road, because it wasn't worth the fight over one assignment, and I just gave them zeros and moved on from there, and just and I let them know that, hey, this was done using methods we didn't even talk about yet in this class. So clearly there were some extra resources used, and no one denied it. no one fought it. I'm like, yeah, okay. So that was it. And then starting now, I just do all my lab assignments, which is nice. I'm not against my lab assignments. There's a lot of positives, which I talk to with my classes about. You can do an infinite amount of practice problems. You get the direct feedback instantly. The only problem with MyLab and that gap is you have to write the problems down. You have to make sure you know how to do those problems. It can't just be a click, I got that one wrong, what's the answer? All right, let me just try to figure out what that answer was and how I modify it to this problem. There's a lot of that. That's the only gap that I don't think we could connect. I don't think we could bridge that gap between here's an assignment, make sure you write it all down, and then submit those answers. But that's my philosophy on homework. I think it's really, really important, and I think if everyone did the homework for the purpose that it's intended for, there would be a much higher level of success. Okay, then the problem I have for today is this 3 over x minus 3 minus 7 over x plus 5. The reason I'm doing this problem is because a comment came through on a previous video where I had the same denominators on a problem like this, and the student was a little unsure on how to approach the process with different denominators. So I wanted to make this video regarding the different denominators. So when we're dealing with different denominators and we're subtracting, you want to find the LCD. So the least common denominator here is going to be x minus 3, x plus 5. Since I have the LCD, I have different denominators, I want to multiply both denominator by whatever factor that it needs. So this first fraction, x minus 3, needs that x plus 5. So I'm going to multiply this by x plus 5. Second fraction doesn't have the x minus 3, so it needs the x minus 3. When I multiply by those modifiers, those x plus 5 and the x minus 3, on the top here I'm going to distribute the 3. So 3x plus 3 times 5 is 15. Here's the main question. There on the video that I posted before, there's the same denominators, but it was just like this. It was a subtraction problem, and the emphasis was on the fact that I am subtracting 7 times x minus 3. So what I have to do is I have to do negative 7 times x minus 3. So it's got to be negative 7. Let me do it over here. Negative 7 times x minus 3. I have to do negative 7 times x, which is negative 7x. Negative 7 times negative 3, positive 21, over the LCD of x minus 3, x plus 5. Then from here, it's just condensing, combining like terms. So 3x minus 7x is negative 4x. 15 plus 21 is 36. Positive 36 over x minus 3, x plus 5. From this next step, you might notice that we have a leading negative here. See, this is negative 4x. And then I have a 36. So I could factor out that negative along with a 4. But when I do that, nothing really happens from there. So I'm going to do that though, just to condense this or simplify it as much as possible, or factor it out. So I'm going to factor out that negative 4. That's going to leave me with x minus 9, because 36 divided by negative 4 is negative 9, over x minus 3, x plus 5. And that would be it. See, typically, if we have like a certain scenario like this, like maybe this becomes like an x minus 3 here. So then you could be like, okay, I could cancel those out. But in this case, we weren't left with that. We were just left with x minus 9. So it doesn't simplify with x plus 5 or x minus 3. But like I said, if this was like an x minus 3, then we'd be able to simplify that out. But in this case, we were not able to. But then that would be our answer. Negative 4 times x minus 9 over x minus 3 times x plus 5. So the key here is that even though we are modifying by a factor of x minus 3, it's still negative 7 times x minus 3. So you still have to multiply by that negative 7, because it's minus. And you want to make sure you're subtracting off all of that. So good questions this week, especially this philosophy on homework question. I like that one a lot.